Hello, everyone, and welcome to What the Fragment. So I'm Adam Powell. I'm a member of the Android framework team, specifically on the UI toolkit. But I've spent a fair amount of time with Fragments over the years here, and hopefully we can go over some interesting information here. So the first thing that people tend to ask is why Fragments? There's a lot of information out on the web as people have used the API, gotten kind of familiar with it, and in some ways kind of gotten bitten by it. There's a lot of complexity there. And in fact, some members of the community have put together a few diagrams of just how complex the Fragment lifecycle can be if you combine it with the full activity lifecycle as well. So you can start up at the top here, and we keep going. And there's some more. Whew, OK, well, we got to the end. So the blurriness that you're seeing here isn't just because it's a low-res version of the image. It's just your eyes glazing over as you try and take all of this in. And this is kind of your reaction after reading over it. So why Fragments? If this is kind of the reaction that everybody's had over the last few years out in the developer community, why is it still something that we're pushing or promoting as a way to build your applications? Well, to start with that, we'll go over just kind of a little bit of history about where Fragments came from. So some of you might have seen a Google Plus post by Diane Hackborn this past weekend, where she went into some detail about the Android component model and how it's really not intended to impose a lot of higher-level architecture on your applications. Instead, it's really just meant to be a series of smarter entry points. So in a traditional program that you might have seen in classes or so on and so forth, you start from a main function and you run to the end, and you might start a message loop in the middle there. And what activities really give you to start with is just kind of a smarter entry point, a place where the system can send you other messages about what's going on to your application, and these are just turned into callbacks on an object instead. So there were some other goals kind of in the design of activities as well, which one of those is that apps always stay in the state where you left them. So in order to do that, you have this well-defined activity lifecycle and a compact state representation that you can use so that the process can die, come back later, restore from that state. All of this is stuff that you're probably familiar with. Also, apps can call other apps to complete a task in the form of activities called with intent. And each one of those flows is represented as one of these encapsulated units in the form of these activities. So over time, activities just started getting big and complex. And basically, the way that you deal with complexity is that you factor out smaller pieces so that you can compose them. Back in the pre-Android 3.0 days, we had this thing called Local Activity Manager that could work in concert with a tab host widget that you can see here in the old Gingerbread Dialer app. So each one of these pieces and each one of these tabs actually contained a full activity. So that kind of gave some weird pieces of the code there in terms of how the code would interact. There are ideas in the activity lifecycle that just really don't make sense in this kind of composed model. And then this happened, and we're not going to talk about that. So larger screens happened, and larger screens mean larger problems. So we have this idea of how do you want to present these multiple small screens worth of UI that you may have already built in an existing application, and then sort of scale that out across other screens. Is there sort of a smaller unit of composition that you could use for that? And so that other unit of composition, spoilers, is Fragments. So this was introduced around Honeycomb to try to solve some of these problems. The first one of these goals, though, was really just to break up these giant activity classes. And this is a problem that happens whether you're dealing just with small phone screens or if you're trying to scale across many different screen sizes. And it's just kind of natural that as app complexity grows, so does the complexity of these kind of big entry points that can kind of grow to be these God objects if you're not careful. We also kind of wanted to fix some of these problems with Local Activity Manager for when you do compose them in these smaller constructs. So you have lots of these abstractions at the activity level that just don't work well when you start composing it this way. These are usually things that aren't quite as well covered as like the core activity state diagram, but they're all cases that still need to be handled in a general purpose solution. One of the other things that we wanted to do with Fragments was to encapsulate navigation state. So the state of your fragments can represent the full state of your activity in a way that can be preserved through state save and restore through a process death. So we have things like an activity local backstack, which some people find useful and some people don't. But managed dialogues was one of the other things that this really tried to address. Dialog fragment is something that a lot of people do use at this point, and it's because you basically get the state restoration for free if you rotate the screen or go through any other sorts of config changes. Back before Fragments, this was handled by just kind of this first-class facility that was provided by activities where you refer to a dialog by its ID. There's this whole other creation process involved in terms of like, yes, I want to create the dialog with this ID. We would persist that ID and try to build everything back up from scratch. And that ended up just being very one-off and kind of awkward to work with. And the final goal that was probably the most obvious in terms of how we pitched the API when it was first released is this idea of decomposing these master detail UIs. So if you have two screens that on a phone might look something like this, where you've got a list of conversations as well as the actual conversation itself as you drill down by tapping into it, use the back button to get back to where you were before. In another configuration, you could take what's essentially the same code and have it look like this. So this is something that you might be familiar with from a lot of UIs that you've seen here. And since then, we kept building on it. So we had View Pager and the Fragment Pager adapter, which a lot of people still kind of think is the way to use a View Pager, just because we don't have a stock adapter for dealing with just bare views. So we've got loaders, which allow you to do similar things of persisting some sort of a request across configuration changes, keep it going whether or not the lifecycle might otherwise interrupt. Ian Lake has a great post up on Medium about this that all of you should go read if you haven't as well. And then we also had this idea of child fragments. So, I mean, if you can nest one level deep in terms of putting fragments inside an activity, well, why can't you put fragments inside a fragment? So that was an idea that had a lot of support in terms of a lot of developers were requesting this, both within Google and external developers as well. And it got added, I think, sometime around the Jelly Bean timeframe. So how did it work out? I mean, some of you kind of already know the answer to this question, but these are sort of what we took as stewards of the API as some of the lessons from Fragments. So the first problem is that fragments are so general that they become really difficult to explain to people. So is it just a pane of a UI, like in the Gmail example? Is it something like dialog fragments and something meant to deal with managed dialogues? Or is it something different altogether, like you can still have headless fragments that can act completely independently of anything else? And we didn't give a whole lot of guidance in terms of how to use these things because we kind of felt like we didn't want to be too prescriptive about it, and that ended up really hurting us. So, of course, the idea of even more lifecycle to manage was really kind of the killer here, and the bugs really didn't help. This is really what killed a lot of people. Whenever I've talked to developers about what they would change about the Fragment API or what problems they have in using the Fragment API, a lot of times what happens is that you build up a Fragment transaction, you commit it, and then something works completely differently from how you expect. It's not particularly intuitive, some of these things, and it might kind of remove the entire point of a bunch of code that you just spent a lot of time writing. So this was another thing that caused a lot of misconceptions. I mean, fragments, they're just kind of like views, right? I mean, you can stick this fragment tag in one of your layout files, inflate it, and you get a fragment for free. In hindsight, the fragment tag was this great piece of syntactic sugar that really confused people a lot more than it helped in terms of just general education. So this immediately made people think that fragment equals view, and that this is on the same level of abstraction. So if we kind of know where things went off the rails, then how might we start trying to use fragments a little bit more effectively? Well, the first thing to keep in mind here is that fragments are roughly equivalent to an activity in terms of the level of abstraction that they act on. They're composable entry points, and their lifecycle and inputs are really controlled by their surroundings. They optionally manage a UI presentation, and they're really kind of part of the whatever in model view whatever in terms of the architectural patterns that you may be using within your application. They're not views themselves, and they're really not meant to be. Seriously, they're not just fancy view groups. Fragments implement UIs just by using views. They compose views. They wire things up to views in order to do something more interesting. And this really kind of comes down to a core idea that isn't communicated all that widely, that we kind of keep this idea of an abstraction hierarchy across the different packages in the framework. The higher level packages are things like Android.app, whereas the views and widgets are further down the stack. And what this means in practice in terms of the organization of code within the Android framework is that anything at a higher level can import anything from a lower level, but not the other way around. And if you go looking through AOSP, you'll probably find a couple of places where we messed this up, and yes, we know it, we're sorry. But overall, it's managed to be a pretty good way of organizing some of this stuff and making sure that things keep a level of responsibility that's kind of appropriate for that type of component. So an example of this is that you might have a fragment that depends on view on click listener in order to implement that interface. This is an example of a fragment just kind of applying policy to a series of views that it's using. Come on. So while fragments can depend on views and implement the interfaces exposed by those views, it's important to remember that the views have no knowledge of fragments. That fragments really kind of sit as the policy layer above whatever UI that you've built visually and out of the structure that is used to generate input events, so on and so forth. So really, they're kind of a glue component in this case. They provide coordination of these different view components or even of other components within your app. They allow you to wire up the view events, the input events that you may be generating from those views, and tell them something interesting to do. And all of that ends up being driven by a knowledge of the external lifecycle. What's going on outside the app? What's going on outside the context of that particular fragment or activity? So this is something that others have definitely said, and I will totally echo here. Don't use a fragment when just a composite custom view group or even just a layout resource that you can use in an include tag will do the job better. A lot of times people use this as a point of where they can pivot, where they can decide what type of UI to show based on other conditions. And between the resource system and custom view groups, you can solve that problem without getting into lifecycle constructs. The real question to ask when you're talking about using a custom view group or a fragment in these cases is, does it implement mechanism or does it implement policy? Is it an isolated widget that generates its own input events? And these might be really complex as well. I mean, we've got some things in more recent versions of the support library like coordinator layout that are able to impose very complex behaviors on their child views. Things that you can push and pull and move around, swipe to dismiss, so on and so forth. But all of those essentially are still just the user acting on the UI. You might be able to swipe a snack bar away. You might be able to click an apply button on a snack bar in a coordinator layout or something. But what that actually means to the application is policy that's imposed by some other component. And that's more where fragments sit in the layering. So we also can't talk about fragments and dealing with some of the associated complexity without talking about saved state. So the navigational state of your application is partially composed by the fragments that are currently attached to it. These may have changed over time. Contents may have shifted during flight, so on and so forth, where if you have something like master detail UIs, then you might have a very different fragment that you're showing if you were drilled into item A versus drilled into item B in that list. And that's something that ideally you don't want to have to track yourself in terms of other state as it gets restored, as your process dies, you come back into it, so on and so forth. So that means that setup of fragments is conditional. And this is another one of those kind of weird things that everybody sees when they first start working with fragments. Well, why am I doing this extra check here when I'm setting up this initial state? And that's partially because the fragments are going to be restored as part of that onCreate call. Now, this has historically gotten a little bit weird in that if you're dealing with child fragments, when that reinflation happens, really wasn't consistent with the way that it happens with fragments that are attached to activities. Now, over the last several months, we've really kind of we've dived into the Fragment APIs and tried to clean up a lot of these cases where the behavior was just unexpected or inconsistent, because these are the things that really made everybody hate the API to start with. So as of Android N and support library version 24, which is available as part of the preview SDK right now, child fragments are, just as with activity-attached fragments, they're consistently reinflated during the super.onCreate call that you make within your own code. So that way, after you make that call, you know that those fragments that were restored from instance state are attached to your activity. You can do find fragment by tag and actually expect to find it there. You won't end up with duplicates when you try to deal with that case. Thank you. So that alone makes things a whole lot easier to deal with. What about the legal state exception? The illegal state exception? Which one? We'll get to it in a minute. OK. So again, we keep coming back to this idea of fragment states and that giant diagram. So how do we just stop worrying and love the life cycle here? Because every one of these stages of the life cycle really does represent a significant event that can happen to your application. And just because we have a lot of them there doesn't necessarily mean that you have to care about all of them all the time. A lot of fragments that you'll write will only implement a couple of these methods, but just having all the options there can be really overwhelming when you're just looking at documentation. So, you know, that big flowchart, like I couldn't tell you everything on that big flowchart at once off the top of my head either. But the nice part about this is that you really don't have to hold all of that in your head at once. Because even though those interactions look very complex, really the fragment lifecycle is driven by what's essentially a single integer value. So this is straight out of the Fragment source code, where we have these 6 states that fragments move between. And the nice thing about these states is that this isn't like a completely connected graph of states. This is linear. So when fragments move from one state to another, they move through all of the other states in turn, dispatching the appropriate methods to the fragment to deal with those lifecycle events. So this leads to something really kind of convenient, which is that all you need to think about is what invariants do I need to enforce for my new state? You can keep your thinking very much constrained to each one of these individual lifecycle methods so that you don't have to worry about the state of the entire application in aggregate when you're dealing with this. More importantly, you can say, what minimum state will this component be in, or what can I count on? Since, again, the fragment states are linear. So if you know that you're up all the way at the resumed state, you know that you've been through all of the other methods. And this is one of those things that kind of seems obvious in hindsight. But again, as you're looking through the smorgasbord of methods that you can override on Fragment itself, sometimes this kind of gets lost in the noise. So let's go ahead and talk about a few other things. Talked about one bug fix that was pretty significant, which is that the child fragment manager state is guaranteed after the super.onCreate call. Now this is subtly different from what I said earlier about restoring fragments from instance state, because there was this really kind of a fun bug that happens. So how many of you use execute pending transactions for some part of your work with fragments or have tried in the past? OK, keep your hand up if you ended up regretting doing that during a debugging session later. OK, yeah, that's a pretty close match for some of that. So execute pending transactions is this really handy method on the Fragment manager that tells it, OK, all of those things that you've queued up with fragment transaction.commit, do all of them right now, all of them that you've got pending. And that's got a couple of kind of interesting issues with it that we'll get into in a minute. But one of the interesting things about that is that you have expectations after that call. Specifically, if you've committed one or more fragment transactions before that, then you expect those fragments that you've committed in that transaction to be brought up to a particular state in the lifecycle, usually matching the container. Well, it turns out that that wasn't actually how things worked. Some of you probably found this out. And this, again, came down to this idea of what happens with child fragments. And you're probably noticing a bit of a theme here. So what would happen instead is that the child fragment manager itself wouldn't be brought up to the new state until long after the parents on create returned. So all of these invariants that should make it a lot more easy to reason about your program especially when you're saying that, hey, resolve everything right now, execute pending transactions. Well, all that just kind of went out the window. So that made things a lot more difficult. That's now fixed. So again, you know that you don't have to worry about that after the call to super.onCreate. So execute pending transactions had another kind of problem as well, which was that it makes everything happen right now. And the issue with that is that different parts of your program might be committing Fragment transactions at different times. So as soon as you say execute pending transaction in one piece, you may have just caused a side effect that affects some other library that you imported that uses Fragments and you didn't even know about it. So we went ahead and we added a commit now method to Fragment transaction, which basically does the same thing, but really kind of what you wanted instead, which is, no, just this transaction, commit this one right now. This does have one particular limitation, which is that you can't deal with fragments on the back stack if you use commit now. Just because if you have other Fragment transactions pending, you don't kind of want to create inversions in your back stack in terms of when those really apply. We also added a fragment on attached fragment method to match the fragment activity and activity on attached fragment method. This is kind of useful when you want to go ahead and configure a fragment as it's being attached to its parent. If you want to do any sort of injection of dependencies, if you want to do any sort of wiring up of listeners within that local activity for other events that it might publish, this is a pretty good time to do it, except there really wasn't a good place to do this with child fragments before. This was something that was entirely skipped. You couldn't even do it in the parent activity if you wanted to, because it was only ever called on the parent activity if and only if the fragment was attached directly to the activity, not any of the children. So a few other notes that are kind of useful here. This is one that some developers ran into fairly recently as we fixed some other bugs around fragment transitions, which is that to obtain the state of a fragment transition, we have to interrogate the fragment. We have to call a method on the fragment to get the transition values and what it should do. But in order to make that make sense to that fragment, we have to bring the fragment up to the created state before we ask it about the transition. So what that means in effect is that we have to bring some fragments up to the created state before they become fully attached or before they replace whatever fragment that they were replacing before. So this is one of those things that's good to be aware of. Don't assume that just because your fragment goes through the attach and create steps that all of the other surrounding state about a fragment transaction has necessarily happened yet. Again, this is something that you want to make sure that you keep your thinking within a fragment implementation scoped just to that fragment. Make sure that it's not trying to take on responsibilities outside of itself. And again, they really work best when they can behave as isolated from their surroundings. One of the things that I see people do a lot is that when a fragment becomes attached, and again, just because you have problems with state restoration of more complex objects, it's pretty common for people to say, okay, well, when I get attached to my activity, I'm going to go ahead, grab the activity, and go fishing. I'll go ahead and check out if I can find other fragments, other sibling fragments by tag, grab any other sort of associated information from that activity, downcast it to a specific type, so on and so forth. And while this ends up being pretty convenient, it also means that those fragments suddenly become a whole lot less reusable elsewhere. And while you may not care about that right from the outset, it is one of those things that tends to come back and bite people later on. And then they wonder, why didn't we have some other facility to do this, to do a cleaner injection of the dependencies, so on and so forth. Okay, so that was a lot of information really fast. And some of it probably didn't answer a lot of the core questions that you may have had coming in here, which is, I really don't like this API that I've used. Why should, change my mind? Why should I go back and give it another chance? And really the core issue here is that apps aren't getting any smaller. So when you start working, especially across large teams and across code bases that have lasted for a very long time, architectural patterns don't end up being universal. And this is part of what Diane was trying to get to in her post over this weekend as well. If you have a very long-lived code base, then what was popular and the obvious way that everyone should build their apps back when the code base was started isn't necessarily true when you're maintaining it years down the road. So one solution to that is to try to create standard, smarter components. So how many of you have taken a look at integration steps for some library for Android, and you see something that looks kind of like what's on the slide here? OK, go ahead and add this snippet to your onCreate, this other thing to your onStart, this one to onStop. I'm pretty sure that some of our own libraries from Google have these types of instructions as well, things where you need to call some particular method from some part of your lifecycle. And really, that just makes these integrations really kind of messy. So instead of that, well, we could just have, well, add this fragment instead, and we'll go ahead and take care of those extra lifecycle steps. And that suddenly makes that a lot more reusable and a lot less error-prone. And the nice thing about this is really that, oh, or even better, you can just use one of these tags. I mean, even though we had issues around kind of general education around fragments on what they could do, it's really powerful to be able to say, here's a piece of my UI. I just want to drop this completely self-contained component here and then not think about it. To be able to just configure it, possibly from other XML attributes as specified there, and then just let that component do its thing. So the idea here is to really try and provide these single points of high-level integration that everyone can use. And that last part is really key. Again, not everyone is going to be using the same architectural patterns that your app does, and your own app may not use those patterns the same way over time either. But fragments are kind of uniquely positioned here. And that's because fragments really closely mirror that activity lifecycle. There are a few differences here and there, but by and large, like as you're thinking about invariants to enforce within a fragment, they really match what you do with activities as part of that core entry point idea for Android components. So that means that essentially they can sit below that level of abstraction of your higher level architecture that you impose upon your application. And that makes them reusable as components in the same way that views are reusable to fragments. So when fragments are communicating with the rest of the world, you really need to be careful about the types of configuration dependencies that you end up creating. Again, this comes down to that issue of, are you going fishing in your parent activity or in your parent fragment for that matter for other dependencies, and is that fragment going to blow up if those things aren't there? Are those dependencies documented? How is someone who's using that fragment necessarily going to know that that's a requirement? Now, in a code base within a particular team, again, this may not be a problem, but as things grow over time, we tend to see a lot of these patterns show up. And that means that you really do need to consider your audience as you're building these things. If you're building libraries, the answer to this is going to be a lot different from if you're just building another screen within your own application. In your own application, sure, go ahead and take a dependency on some internal component. I mean, it might help, it might hurt, but at the very least, you're not passing this out to the rest of the wider world. And also, if you are offering the ability to use fragments that are these standalone drop-in components, the onInflate method is sorely underused in some of these. So this lets you do the same thing that you do with views. Specify some configuration attributes. It might be something like an API key. It might be something like any other sort of information that you need to pass to that fragment as arguments. But you can do it without having to muck around with it in code necessarily during that initial startup phase of your application. Because again, you want to try to have one integration point with these things. Thank you all for coming.